Now going to question 3, this is a question type that we refer to as linear with heavy unit conversions. So here we can start by describing our variables. We're told that W is the number of hours walking, and R is the number of hours running. So if we lay out the 3 miles per hour, and that's 3 miles per hour walking, so we'll combine that with the number of hours walking, and so that's W hours over 1, because anything's a self over 1. And the thing to notice is that the hours cancel with hours. So now, once again, we laid out the rate, 3 miles per hour. And when we notice that the only other thing we have as far as the walking is the number of hours walking, that's in the numerator because it's not a fraction. Any number that's not a fraction is really itself over 1. So we have hours on the top, hours on the bottom, and it actually works to cancel perfectly. 1 on the top, 1 on the bottom. And this all pertains to the walking. Now, for the running, we know that we have R hours running. So R hours, any number is a self over 1 again. And the running rate is 5 miles per hour. So 5 miles per hour. So now, just like the walking miles, the unit hours cancels with hours. So we can cancel those both out with each other. And so right now, after everything cancels, this is a certain number of miles, and this is a certain number of miles, which makes sense because the question tells us that there were 14 total miles. Let me go ahead and shrink that so I can write better. So that right there is 14, and the unit is miles. So everything is working out great because we had miles at this stop, miles at this stop, the hours canceled, and it left us with miles in the end. So we've used the units, we've used chemistry style unit conversions to confirm that this is all set up correctly. But now that we know it's correct, we can get rid of all these units and see it a little more clearly. So we have 3W plus 5R equals 14, and that is answer choice A.